brain is a remarkable organ. It's responsible for producing every thought, action, memory, feeling, and experience of the world around us. As we age in the fetus, the developing brain produces tens of billions of cells that move to different places of the brain and prepare us for life. Contrary to popular belief, the developing brain doesn't just stop at birth or childhood. It's recognized that in a few unique areas of the brain, new cells are regenerized throughout life in adulthood. Now, this phenomenon is known as neurogenesis, and it's implicated in many types of functions such as learning and memory, but also the regeneration of the brain following injury. The cells that are important in developing all the different cell types of the brain are known as brain stem cells. These brain stem cells are interesting and quite smart because they try to remain dormant throughout our lifetime so that their population can be maintained indefinitely. However, when they're activated, they come out of their dormant state and they produce all the other different cell types that are needed in our brain. However, sometimes this isn't the case, and these brain stem cells may become activated either prematurely or in a wrongful manner. And what happens here is this population dwindles and dies off. This is implicated in a number of neurodegenerative disorders. Now, we know what happens at that end of the spectrum. However, what happens at the other end of the spectrum remains unclear. Now, I know what you're all thinking. Brain stem cells sound amazing, so why wouldn't having more of them be advantageous? And that's where my thesis work comes in. I've developed a novel genetically engineered mouse that has never been used before, in which we can switch these brain stem cells into a hyperactive state. The results are astounding. We see that these cells lose sense of self. They not only are not able to produce the other cell types of the brain, but they start producing more brain stem cells. The implications of this in cognitive functions are very negative. And what we see in these mice is that they have impaired in learning and memory abilities. Moreover, it doesn't just stop there. These mice are also more susceptible to tumor initiation in the brain. This project has had implications in not only understanding the causes of neurodegenerative disorders, but also has implicated in many different cancer initiations. With that, I hope that I've convinced you that, at least in the context of the brain, too much or too little of these cells is not a good thing.